This video introduces a synthetic data generation tool for vehicular trajectory data developed within the GreenDatAI project. The tool aims to produce individual mobility data in geographical areas where no local information is available, exploiting open mobility data available in other areas of the world. The method developed consists of a pipeline where we have an online and an offline phase. In the offline phase, open mobility data are processed to extract spatial locations where vehicles are stopped and their corresponding trip timings. And the online phase remaps spatial locations and timings to the destination geographical areas, introduce a controlled randomization and rerouting trips over the local road network. Once launched, the application server starts an initialization phase where first a set of pre-computed individual mobility networks is loaded, and then through a call to OpenStreetMap, the road network of the area of interest is downloaded. In our case, located in the city of Porto in Portugal, which is the location of one of the use cases of the project. Once the server completed this phase, we can call it either through a simple curl request where we specify the number of users we want to compute, or through any Python script that asks a number of synthetic users to be generated and then visualize them in an appropriate way. The output provided by the tool is a sequence of GPS-like points composed by vehicle ID, latitude, longitude, and timestamp. The visualization shows the area of interest and each of the sequence of trajectories corresponding to each user, each covering several days of simulation. We can see that users cover different parts of the city depending on how they are mapped by the algorithm. The trajectories are composed by a quite dense set of points in a sequential order, and we can observe that all the synthetic trajectories generated visit a single common location, which is the headquarters of Inestec, since part of the use case involves to have synthetic users that have this place as a working location. And indeed, if we scan all the users generated, we can see that all of them stop in this location. Testing over hundreds of synthetic users in the geographical area of Porto in Portugal revealed a coherence between the generated data and the road network structure of the area, and runtimes are sufficiently low to allow large-scale simulations even with commodity machines. The current ongoing work consists in the deployment of the tool within use case 2, where the tool is used to estimate battery consumption between consecutive stops at the recharge station, and an improved randomization for the generation of synthetic data. The code is available on the GitHub repository of the project. Thank you for listening.